6.1, an introduction to vectors. So one thing that we're going to talk about in vectors is magnitude, or this is called size. Okay, it's a quantity that can be specified by one number. Okay, and this number is called a scalar. So such as age, volume, speed, mass, temperature. Okay, so whenever you think about a scalar, just think of just a number. Now, a vector is a mathematical quantity that has two things. So it has both magnitude, so it has a number, and it has a direction. Okay, for a complete description. So weight, because that weight has to do with gravity, velocity, okay, what way you're going. Are you going to the left, to the right, east, west, okay, or friction? And again, gravity. A vector can be represented by a directed line segment. The directed line segment has a length called the magnitude and a direction indicated by an arrowhead. Okay, wherever that arrowhead is pointing, this right here is telling you which direction it's moving in. So if we had the same line, but this arrow is pointing down, these are moving in opposite directions. Okay, so you have to just pay attention to the arrow. So here's an example. We can say that a plane is traveling at 500 kilometers an hour. Okay, that would be a scalar. That's it. It's just talking about the speed. Okay, if we say that a plane is traveling at 500 kilometers an hour northeast, then all of a sudden, this northeast, this becomes a vector. So instead of being a speed, right, speed is here, this is now velocity. Since we have both speed and a direction. Okay, and the magnitude of the vector is always non-negative. Okay, so when we're actually talking about the magnitude, we're talking about the absolute value of, for example, AB. Okay, so magnitude, we're just focusing on the number, and then if it's positive or negative, that would be the direction. Okay, again, vector, we have both magnitude and direction. Okay, we name each directed line segment by tail to head, such as AB or BA. Okay, so in this example here, we have this line, we have this vector, I should say, and we go from tail, which is A, to head, which is B. So AB is the vector, and it's also the direction. Whereas in this one, if we go B to A, because we have to go tail to head, this one would be BA, and again, the direction is BA. Now, opposite vectors are two vectors that are opposites. So two vectors that are opposites have the same magnitude, but point in opposite directions. Okay, so for example, A to B could be vector. We could either call this vector AB, like this, or we can just call it vector V. Okay, V and U are very, very common when we're talking about vectors. Okay, so if we're going in the opposite direction, so again, same magnitude, so like the length here is the same, we can see that, but the arrow is going in the opposite direction. So in tail to head notation, this would be negative AB. Okay, so those are opposites. So AB and BA are opposites, and the magnitude of AB equals the opposite direction, the magnitude of BA. Okay, AB and BA are going to have the same magnitude there. This means that the vectors are parallel, but point in opposite directions. Vectors can also be represented by lowercase letters such as V or negative V. Again, that negative sign is the direction, right? Opposite direction. V and negative V have the same magnitude, but point in opposite directions, so they are opposites. Now, naming vectors. We can name vectors by using the coordinate system as well. Okay, so an example is if we have a vector A, so again, vector A equals 3, 0. This means that vector A has its tail at the origin. So for example, if we had like an X and Y axis, the tail would be here. I'll get another color. The tail would be here. And then its head would be at 3, 0. So it would look like that. Okay, and this vector has a magnitude of 3. And then it's moving to the right, so this vector would be positive, right? It's going east. Okay, how we denote the magnitude is with these 2 bars. Okay, the magnitude of vector A equals 3. Okay, and please note, if we have negative vector A, what that would be is it would be going this way to -3. So the coordinate here would be -3, 0. But the magnitude itself stays the same. Let's send that. Okay, the magnitude itself would still be 3. It's 3 units long. So that negative, again, is just highlighting which direction it's going into. And then these two would be opposites. Vector A and vector -A. Okay, now equal or equivalent vectors, okay, can be called either one. And they're equal or equivalent if they have the same direction and magnitude. Okay, that obviously makes sense. They have to be identical. Okay, another thing is if they have the same direction and magnitude, another name for it is called coincident. And this is going to play a role in a couple units. So vector P is this long and it moves east. Vector Q is the same, this long, it moves east. It doesn't matter where these start or end. Okay, like say for example, this was like an X and a Y axis. It doesn't matter if they start different on different like values here, X and Y values. Okay, they're still equal or equivalent if they have the same direction and the same magnitude. Okay, so more about equal vectors. 2 vectors, A, B, and C, D, are equal or equivalent if and only if vector AB and vector CD are parallel to each other, and the direction from A to B is the same as the direction from A to D. Okay, so A to B, same length, and it's going in the same direction as C to D. Okay, so just a little bit different about the way we are, the notation that we're using. This time we're using AB and then CD. Okay, again, tail to head. Oh, it's very, very common to call this tail to tip, okay, but it's tail to head. The magnitude of AB equals the magnitude of CD, okay, obviously the lengths are equal, right? Magnitude is kind of like a length, but now that we're dealing with vectors, we're calling it magnitude, okay? And this can be denoted as the magnitude of AB equals the magnitude of CD. Okay, so let's take a look at example 1. So we have a rhombus here, rhombus ABCD, and it's 2 diagonals. Okay, so rhombus ABCD, and the 2 diagonals AC and BD, and they're drawn as shown. So we're going to name vectors equal to each of the following. So what vector would be equal to AB? So AB is here. Another vector that's going in the same direction and has the same magnitude would be this one, DC. And we have to specifically call it DC, not CD, because it's going in the same direction, tail to tip. So we can say BC. Okay, now B, DA. DA is going kind of north, if we talked about never eat shredded wheat, northwest, right? DA. We can see that CB also goes in the same direction. So CB. And it has to be in that direction. Okay? EB. So if we have E going up to B, that's just directly north. So another vector that is going directly north is GE. Okay, and then finally we have AE. So that's going east, AE, and then we have EC also going east with the same magnitude. Okay, so last definitions here, geometric vectors. These are vectors that are considered without reference to coordinate axes. So what that means is like an X and a Y. Okay, so they're not referencing X, Y, they're kind of more like this picture here, where there's just in general, okay? Or maybe northwest, east, south. Whereas algebraic vectors are considered with reference to a coordinate axis, and this is usually needed in applications.